Welcome to the Deep Dive, the show where we really try to cut through the noise and give you the insights you need fast.
Glad to be here.
Today, we're not just looking at numbers, are we? We're kind of charting the flight path of an industry that's, well, it's transforming right before our eyes.
That's a good way to put it.
We're diving deep into the, really fascinating world of aerospace 3D printing. It's a technology that's absolutely revolutionizing how we travel, how we explore, even defense.
Yeah, it touches so much.
Think of this as your, let's say, shortcut to truly understanding a field that seems complex but is incredibly important.
It really is. And it's a field just brimming with innovation. So our mission in this deep dive really is to unpack the current trends, maybe peer into the future opportunities a bit.
Challenges too, right?
Oh, definitely. And examine those critical challenges shaping the industry. We want to help you grasp what's really happening and, crucially, why it matters. Why it matters for all of us.
And when we say matters, we definitely mean it. The sheer scale of what we're talking about here is, well, it's kind of breathtaking.
The numbers are pretty stark.
Yeah. To give you a sense, the global aerospace 3D printing market was estimated at over $3.4 billion. That was just for 2024.
2.4 billion. Yep.
But here's where it gets really interesting. It's projected to skyrocket. We're talking over $15 billion by 2032.
15 billion. It's huge. And that means a compound annual growth rate, the CAGR, of 20.5%.
20.5%. That's...
I mean, to put that 20.5% CAGR in perspective,
yeah.
That's the kind of growth rate you usually see in, like, disruptive software companies.
Right. Not heavy industry, usually.
Exactly. Not heavy industry. So it tells you this isn't just, an evolution. It's really a revolution in how we're building the future of flight and space.
Wow.
And that current market size, the 3.4 billion, it reflects this incredibly strong demand that actually goes well beyond just aerospace itself. We're talking about a ripple effect across defense, healthcare, automotive, transportation, medical, energy, a whole host of industrial applications too.
So, okay, what exactly is fueling that kind of explosive growth? Because, like you said, a 20.50% CAGR doesn't just happen by accident.
No, absolutely not.
Is it one or two key things, or is it more like a perfect storm of factors coming together?
It's definitely a synergistic effect. There are several really clear factors driving it.
Okay.
There's the increasing demand for low-volume production of aircraft components.
Yeah.
Think specialized parts or maybe limited runs of new designs. 3D printing is just perfectly suited for that.
Right, tailor-made stuff.
Exactly. Then there's the absolutely crucial need for lightweight components in aerospace. I mean, every single ounce you save translates directly into better fuel efficiency.
And better performance.
And enhanced performance for the aircraft, yeah. We also see this relentless drive to significantly cut down component production time.
Faster turnaround.
Much faster. Along with the pursuit of, well, cost-effective and more sustainable products, minimizing waste, which is a big plus.
Sustainability is key now.
It is. And underpinning all of that is the overarching demand for rapid prototyping, getting new designs from concept to the test phase faster than ever before.
So we're talking efficiency, cost savings, lighter components, better performance. It really hits all the sweet spots, doesn't it?
It really does.
Do we have maybe a real-world example that kind of illustrates these trends in action, something concrete?
We do, actually. Consider the recent acquisition of 3DMF by Safran Nacelles.
Okay, Safran Nacelles, big player.
Exactly. And this isn't just some corporate maneuver. It's really strategic investment. It's aimed squarely at expanding their capabilities in something called high-energy hydroforming, or HEHF, for metal products.
High-energy hydroforming, HEHF.
And this directly advances aeronautical 3D printing because it allows them to create what are called monolithic integrated structures from thick plates of metal.
All right, for listeners who might be, scratching their heads a bit at monolithic integrated structures, could you break that down for us? What does that mean practically?
Absolutely. Good question. Imagine creating a complex airplane part, maybe like an engine nozzle or an air inlet lip,
Okay.
as a single seamless piece instead of, welding or bolting together multiple components like you traditionally would.
Okay. One solid piece.
That's basically what monolithic integrated structures means. They're incredibly strong and they're lighter precisely because there are no weak points from assembly. It lets you create these complex, strong, single-piece structures that just weren't feasible before, especially for critical parts facing extreme conditions.
That is a powerful illustration. It shows how companies are making really serious strategic bets on this technology's future.
Definitely.
Now, speaking of strategic moves and where the money's going, where exactly is this revolution taking hold the fastest around the globe? What does that global footprint look like?
Right. Well, if we look at the global market shares from 2023, uh, North America clearly held the largest slice. It came in at approximately 35%.
35%. Okay, the leader.
Yeah. And this dominance is largely driven by the early adoption of aerospace 3D printers, which in turn was fueled by pretty robust aviation and space exploration initiatives.
Makes sense.
And just a consistent demand for those lighter components we talked about. What's particularly noteworthy, though, is that North America's share is actually projected to edge up slightly to 36% by 2024,
Okay, still growing its lead then.
and boasting the highest regional CAGR, around 9%. A big influence here is the rise of small and medium-sized firms, SMEs.
Oh, interesting. Not just the giants.
Exactly. These SMEs are leveraging 3D printing for specialized parts, for prototypes, without needing those massive capital commitments you'd associate with traditional manufacturing, sort of democratizing innovation in a way.
That's a really great point about SMEs opening up the field. How did the other regions compare? Europe, Asia Pacific?
Well, Europe followed North America with a pretty solid 30% market share in 2023.
Okay, number two.
A key factor there is the European Union's really strong focus on sustainability and environmental regulations. That naturally encourages adopting additive manufacturing processes because they tend to reduce waste and energy usage.
Right, the green push helps.
It does. Meanwhile, the Asia-Pacific region is experiencing really accelerated growth. They held approximately 25% of the market.
Hmm.
Countries like China, Japan, India, they're leading with significant investments in aircraft innovation and infrastructure.
Building up capability.
Right, which is crucial for producing new airplanes to meet the demand in their rapidly expanding commercial aviation sectors.
Okay, so we've got clear regional leaders, but it sounds like growth is pretty widespread. What about the competitive landscape within this market? Is it, dominated by a few huge players, or is it more fragmented, a dynamic battlefield?
Well, it's intensely competitive, definitely a battlefield, featuring several prominent players.
True.
In 2023, 3D Systems Corporation held a significant share, roughly 20%. Stratasys Ltd. was right behind at about 17%, and EOS GmbH at 14%.
Okay, so some clear leaders there.
Yes, and these organizations maintain their edge through consistent, heavy investment in R&D. They're constantly enhancing and innovating their products offerings.
Makes sense. Constant improvement needed.
Absolutely. And things like mergers, acquisitions, strategic partnerships, those are also key tactics they use to broaden their product portfolios and their global reach.
Standard playbook for a hot market.
Pretty much, we're also seeing an expectation of new entrants joining the fray and just increased competition overall, particularly in North America, expected by 2024. So it's only getting more dynamic.
That sounds like a fascinating race to watch. Now, you mentioned lightweight components earlier as a key driver. Let's talk materials for a second. What role do materials play, especially composites? We hear so much about composites in aerospace.
Yeah, and what's truly fascinating here is how integral composite materials have actually been to aircraft and spacecraft for a very, very long time.
Oh, really? How long?
I mean, literally from things like hot air balloon gondolas way back when, right up to the space shuttle.
Wow, okay.
The source we looked at highlights their use in everything from whole airplanes like the Beech Starship to wing assemblies, helicopter rotor blades, propellers, even seats and instrument enclosures.
So they're everywhere already.
Pretty much. Their primary benefit has always been that significant reduction in overall weight, which consequently leads to increased performance.
Right. But how does 3D printing change the game for composites then, if they were already used?
That's the key question. While composites have been crucial for decades, 3D printing unlocks this entirely new level of precision and complexity. Imagine being able to lay down individual carbon fibers exactly where you need them for optimal strength.
Okay. Intricate placement.
Exactly. Or creating internal lattice structures, these complex internal geometries that were simply impossible to mold or machine traditionally.
Things you couldn't make before.
Precisely. That's the real game changer. And it directly contributes to this heightened demand for 3D printed products using these advanced materials.
It's clear this technology has just immense potential, really transforming how we think about design, about manufacturing.
Absolutely.
But of course, no major innovation comes without its hurdles, its challenges. What are some of the biggest ones that could potentially slow down the widespread adoption of aerospace 3D printing?
Especially given the, incredibly high stakes in this industry. Safety first.
That's a really important question to address head on. because the potential is huge, but the obstacles are real too.
Right.
One significant impediment to market growth is the often incredibly time-consuming nature of post-processing for 3D printed parts.
Fourth processing, what does that involve?
Well, after the initial printing is done, these components often require quite extensive additional treatments. We're talking about things like surface finishing to get the smoothness right.
Heat treatment to optimize the material properties, make sure it's strong enough, removal of support structures that were needed during printing, and often precision machining to achieve the aerospace industry's extremely stringent quality standards.
So it's definitely not just print and fly.
Oh, not at all. There's a lot of meticulous, careful work that happens after the printer finishes its job.
And that adds time and cost.
Exactly. These necessary steps, especially if you're dealing with complex parts, they extend the manufacturing times and they significantly increase costs, which can, unfortunately, mitigate some of 3D printing's inherent efficiency advantages,
Right, it eats into the benefits.
especially for aerospace applications where precision and safety are just absolutely paramount. These extra processes are simply non-negotiable.
Okay, so post-processing time and cost is a big one. What other challenges stand out in this kind of high-stakes environment?
Another really substantial challenge lies in quality management and certification.
The regulatory side.
Precisely. Because flight operations are so critical and the conditions aerospace components face are so harsh, extreme temperatures, vibrations, stresses, they have to meet incredibly strict safety and performance standards.
No room for error.
None. And maintaining consistent quality in 3D printed products is, frankly, inherently more difficult than it is in traditional manufacturing.
Why is that?
Because you can have subtle variations in material qualities from batch to batch, slight differences in printing conditions like temperature or humidity, and variations in how that post-processing is done.
Lots of variable.
Lots of variables. So ensuring uniformity part after part after part is a significant hurdle.
And then getting them approved.
That's the other big piece. Certifying 3D printed components for actual aircraft use requires extensive, time-consuming, and very costly testing and clearance. Regulatory authorities like the FAA in the US or EASA in Europe, they need absolute proof of safety and reliability.
Makes sense.
But that rigorous process can significantly delay broader adoption, simply because of the sheer investment required in both time and money to get that stamp of approval.
Those are undoubtedly significant hurdles: post-processing, quality control, certification. But the industry is clearly pushing forward regardless. Looking ahead then, what can we expect? What future developments might directly address some of these challenges and, propel a market even further, maybe make some of these hurdles a bit less daunting?
Yeah, absolutely. The industry isn't standing still. It's actively working on solutions. We can anticipate significant advancements in several key areas that aim to do just that.
Like what?
Firstly, there's enormous R&D happening in the creation of novel high-performance materials. Materials designed exclusively for aerospace 3D printing.
So beyond the current metals.
Exactly. While titanium and aluminum alloys are common now, the focus is intensely on new composites, new high-strength polymers, materials that promise even better durability, higher heat resistance, and further weight reduction.
Lighter and tougher.
That's the goal. Imagine developing components that can withstand even more extreme temperatures or pressures. That directly leads to even more fuel-efficient and high-performing aircraft and spacecraft.
That sounds like a potential game changer for design possibilities. What about the printing process itself? Is it going to get faster or more efficient to maybe tackle that post-processing bottleneck we talked about?
Absolutely. That's a huge focus. Advances in the 3D printing technologies themselves are expected to significantly reduce production time, directly addressing some of those bottlenecks.
How so?
Well, we're talking about innovations like multi-laser systems, for instance, which can print multiple areas of a part simultaneously, speeding things up considerably.
Okay, parallel processing.
Kind of, yeah.
Yeah.
And also hybrid manufacturing. This is where you combine additive to the printing part and subtractive processes like CNC machining, often on the same machine.
So print and finish in one go.
Essentially, yes. Print the rough shape, then precisely machine the critical features right there. These methods will speed up not just prototyping, but also the production of high-quality end-use parts. That reduces lead times, reduces overall costs, and makes 3D printing much more viable for larger-scale manufacturing in aerospace.
And in our increasingly connected, data-driven world, I imagine automation and smart manufacturing must play a pivotal role too, maybe helping with that quality control issue.
They absolutely will. It's a key part of the future. We'll see a much deeper integration of artificial intelligence, AI, and machine learning, ML, to make these 3D printing processes far more automated and, well, intelligent.
How would AI help?
Think about technologies that can optimize print parameters in real time, maybe using sensors and cameras to monitor the print, detecting potential issues like warping or defects as they happen, and automatically correcting the print settings on the fly.
Wow, self-correcting printers.
That's the direction, leading to increased precision and fewer errors right from the start. Furthermore, you'll see smart manufacturing techniques, things like constant data monitoring of the print process, predictive maintenance for the printers themselves, all enhancing the overall reliability and the quality of the final 3D printed components.
That real-time feedback loop sounds critical.
It is, especially for an industry where, as we said, safety and precision are absolutely non-negotiable.
What a deep dive this has been. It's just so clear that the aerospace 3D printing market is truly at a watershed moment, isn't it? Poised for really immense expansion.
It certainly feels that way.
It just has such game-changing potential for improving efficiency, cutting costs, boosting performance all across the aerospace industry. And it's thanks to its ability to create these incredibly lightweight, sophisticated components with minimal material waste.
Indeed. And the continued development of those sophisticated materials we talked about, combined with increases in printing speed and efficiency, plus the powerful integration of automation and AI, it's all going to continue pushing the boundaries of what's even possible.
But the challenges remain.
They do. Addressing those challenges, the post-processing, ensuring a robust quality control, streamlining that certification process through maybe more standardization and innovative solutions, that will be absolutely crucial for wider and more rapid adoption.
So wrapping this up, what does this all mean for you, our listener? As we look to the skies and even beyond, what does the rise of aerospace 3D printing truly signify? Not just for how parts are made, but maybe for the very future of how we design, how we build, how we even think about flying, about space travel, and maybe the boundaries of what's physically possible way up there in the skies above us.
It really makes you wonder what the next generation of aircraft and spacecraft might look like, doesn't it?
It certainly does. Something to ponder.